Hey guys, this video is on histograms. This is just kind of like an instructional video. I'm going to kind of talk about some important things about a histogram. We'll answer some practice questions on this histogram. This is a great way for you to study for any test or quiz you might have coming up, or if you just really don't understand histograms or aren't feeling confident about histograms, then you can watch this video and take a listen and make sure you know all the different parts and you're able to answer some questions. Okay, so this histogram here I've created is about teacher heights. Now, I don't know why somebody is polling teachers on how tall they are. Maybe the school or students are just curious about how tall. I don't know. But we have this data, this information on how tall teachers are. We have our heights down here on the x-axis, and our heights are in inches. And then up here we have the number of teachers. So your y-axis is your frequency. Okay, frequency is how many teachers are this tall. Now, a histogram is different than a bar graph. A bar graph, most times, is categorical data. Remember how we talked about the difference between categorical and numerical data? This is the type of answers you get. This is the type of data you collect. Bar graphs are often used for categorical data. For example, what is your favorite pet? Okay, we have a bar that represents maybe dogs, a bar that represents cats. Okay, histograms, you have these ranges. You have these bins, which are ranges. So we are looking at heights. That is numerical data. We're getting numbers. Something that's very important about our bins is that the sizes are the same. So in this first bin, we're talking about heights between 56 and 60. How many different heights fit into this bar? 56 inches, 57, 58, 59, and 60. There are 5 different heights that go within this bar, 5 numbers. What about the next bar between 61 and 65? 61, 62, 63, 64, 65. There's also 5 different heights that go within this bar. 5 heights in this bar, in this bar, in this bar. Okay, each bin includes 5 heights. Other histograms might include 10 different heights or 10 different numbers. Okay, so whatever your range is, it needs to be the same for every single one of your bars, or it's going to be really misleading. Okay, so you don't want a bar from 56 to 70, one super long bar, and then one bar that's from 71 to 75, because it's not evenly distributed. Okay, so that's another thing to note about histograms. Okay, so when I get a histogram picture, probably the first thing that I like to do is write my frequency. And I tend to do it on top of these bars, so it makes it easier for me to see and read, even though a histogram is already pretty simple to read right away. How many teachers are within 56 to 60? Okay, my frequency is 4. There are 4 teachers that are represented by this bin. What about the next one? 61 to 65 inches? That's going to be... My drawing is not... Here, let me edit this. This should really be like the halfway point. What's halfway? Between 6 and 7. Oh, sorry, 6 and 8. 7. Let's say 7, because you can't have half a teacher. There's no such thing as 7.5 teachers. Okay, so 7. Let's count that as 7. All right, my next bar is 8. You know, that's a little bit too tall too. Oh my goodness. I should not be an art teacher, huh? Okay, this next bar, that one looks pretty good. That's at a 6. And then this next bar here, not quite 2. We're gonna have 1 teacher. All right. Another thing I like to see is how many teachers did I ask in total? We're gonna add up all the bars. What is my total? And knowing that total is also very helpful when figuring out our percentages. So what's 4 plus 7 plus 8 plus 6 plus 1? Let's see, this is 10. 11, 19, 26. Is that right? Did I do that right? Yeah, 26. So this data is about 26 teachers. We asked 26 teachers what their heights are. Okay? All right, so now let's figure out our percentages. Let's practice figuring out our percentage. Why do we figure out our percentages? It's nice to know how much of our total is within these bars. Just because this bar is the tallest does not mean that the majority of our teachers are this height. Okay, majority is over 50, over half. Are there over half of 26? That's 13. Half of 26 is 13. Are there 13 teachers within that range? No. So just because the bar is the tallest doesn't mean it's the majority. It's nice to know our percentages. Okay, so percent is always out of 100, right? Because a perfect score is 100. If we charge our computers, we want 100%. So to figure out your percent, we're going to do our part, and this is also in your digital notebook, part over whole times 100 will give you your percentage. Okay? When I mean part, I'm talking about how many, what's the frequency of this bin? What part of this bin is out of the whole thing? So your part is your bin size. So if I want to know the percent between 56 and 60, we're going to take our part, 4, divided by our whole. Our total is 26. 4 out of 26 times 100 to get our percentages. Okay. Let me get my calculator. Okay, I have my calculator here, but you are using the Desmos calculator, so pull that up from Clever if you need to. I'm going to write what you would type into the calculator. Okay, so for this first bin, 4, your part is 4 out of 26 times 100. What'd you get? Try it out. You can pause this video. I'm going too fast. Am I going to beat you? Try it out. I got 15.38. We're going to round that to 15%. Okay, so this first one is about 15%. Well, you can't see that color very well. It's pink. It's hot pink. I don't know why it's so dim. Okay, next one. 7. Let's figure out what percentage is between 61 and 65. So we're going to do our frequency 7. Our part is 7 out of 26 times 100. That's what you would type into your calculator in Desmos. I got 26.9. We're going to round up to 27. Okay. Next, what percentage is within the 66 to 70 inches? That bin, we're going to type in 8 out of 26 times 100. $30.7. We're going to round up to 31%. Remember our rounding rules, 5 or more, raise the score. So if your decimal is 0.5, 6, 7, 8, or 9, we're going to round up to the next whole number. 6. We're going to type in 6 out of 26 times 100. And then this last one, I'm going to go ahead and write 1 out of 26 times 100. Figure out those percentages. I got 23 here. And 3.8, I'm going to say 4%. Now, if you add up all your percentages, you should get it very close to 100. In a perfect world, if we didn't get all these decimals, then your percentages will add up to 100. Because you can't have more. You can't have more than 26 teachers if you only ask 26 teachers. Okay, but with our decimals, we rounded, so maybe it's closer to 99 or 101. But your percentages should be perfect 100 or very close. Okay, I'm going to go ahead and erase this. This is how you figure out your percent. Okay, let's do some practice problems now. Talking about, let's answer some problems. Now that we have all the information we could possibly have about this histogram and we understand what it's talking about, let's answer some questions. Question number 1. What percent of teachers are taller than 71 inches? Okay, taller than 71 inches. We need to find our bins that are taller than 71 inches. I know 71's right here, but is this the only bin? Is this the only range that is taller than 71? What if you're 76? What about this one teacher in this bin? Okay, so we need to include both of these, not just the 71 to 75, but taller than, that's 71 and up. Okay, so we're going to add, and it's asking about percentages, so we're going to add our percentages. We have 23% in this bin. We have 4% in this bin. So what percent of teachers are taller than 71? We're just going to do our 23% plus our 4%. We get 27%. So 27% of teachers are taller than 71 inches. Okay, what if it asks you to explain? Woo, explain it. How'd you get that? I would say, hold on, I'm going to write it. Okay, how's this explanation? Taller than 71 inches includes the 71 to 75 bin, which is 23% of teachers, and the, that's not right, 76 to 80 bin, which is 4% of teachers. Okay, so that would be an explanation on how I knew that 27% of teachers are taller than 71 inches. All right, let's answer another question. What percent of teachers are shorter than 66? So because, again, it's not giving me a specific range. It doesn't say what percent of teachers are 66 to 70 inches. It's just shorter than 66. That means 66 is too tall. We want these two bars. Okay, the two bars that are shorter than 66. So we're going to do the same thing. We're going to take our percent. Okay, the 56 to 60, and if it says explain, the 56 to 60 bin is 15%, and the 61 to 65 bin is 27%. Okay. Teachers that are shorter than 66 inches include the 56 to 60 bin and the 61 to 65 bin. So the answer to this one is 15 plus 27. Oh, I should do our percent sign, which is 42%. So almost half. A little bit less than half. Okay, but again, your explanation, why? Which bins are shorter than 66? These two. To figure out the total percentage of teachers who are shorter than that, you need to add the percentages of those two bars. Okay? All right. Let's do another one. Create your own question. There are a lot of things that we can ask about this histogram. We can say, how many teachers are within each bin? That's your frequency. How many teachers are between 56 and 60 inches tall? 4. How many teachers are between 61 and 65 inches tall? 7. How many teachers are between 66 and 70 inches tall? 8. We can even get fancy. We can say, how many teachers are between 66 and 80 inches tall? 66 to 80, that's these three. So let's add them up. 8 plus 6 plus 1. It's 15. So 15 teachers are between 66 to 80. You can say, how many teachers are shorter than 76 inches? Shorter? That's all these bars. 4 plus 7 plus 8 plus 6. 25. What percent of teachers are shorter than 76 inches? If this is, remember, the whole thing is 100%. This guy's 4. So that means these first 4 bars are 96% of teachers. Okay, so you can ask so many questions about this. All right, the last important thing to note about a histogram, okay, is what kind of data it provides. And we talked about this in class extensively. Do I know exactly each teacher's height? Out of these 26 teachers, do I know exactly how tall every single one of them are? Let's look at this one teacher. I know one teacher is really tall. The tallest teacher that I asked is somewhere between 76 and 80. But do I know how tall he is or she is? This is a range. So this one teacher could be 80 inches tall. That one teacher could be 76 inches tall, or maybe 77 inches tall, or 78, or 79. I don't know for sure. All I have is a range. If I don't get my data points, I don't have my numbers, then that one teacher could be anywhere in that range. So histograms do not tell us specific data points. They only tell us the frequency within each range, within each bin. Okay? So what if this said to create a possible set of data? What could the teachers' heights be? What could the 26 teachers' heights be? We did exactly this in our notebook. Let's do it one more time. I know 4 teachers are somewhere between 56 and 60. Okay, so we could have, maybe they're all 56. 56, 56, 56, 56. They're all the same height. Maybe one is 56 and then 3 are 60. Maybe 56, 57, 58, 59. I have 4 heights in inches, 4 that are between 56 and 60. Okay, let's look at our next bin. I'm going to put it on another line. Between 61 and 65, I have 7 teachers somewhere between 61 and 65 inches tall. Pick any numbers you want. Maybe we have a lot in the 60, close to 61, 3 61s, a 62, nobody 63, and then we have a 65. 1, 2, 3, 4, 5, 6, 7. Those are 7 numbers between 7 heights, I should say 7 heights between 61 and 65 inches tall. Let's keep going. 66 and 70. There are 8 teachers between 66 and 70 inches tall. All right. I think, let's see, let's say I'm 66 inches, and Miss Kunath is 66 inches, and Miss Moore is 67 inches tall, and Mr. Spivak is 68 inches tall, and Mr. Marshall is 69 inches tall, and Miss Shirey is 70 inches tall. How many am I at? 1, 2, 3, 4, 5, 6. I need 2 more. Oh, Mr. Fernald is also 70 inches tall. Well, what are the chances of that? And then who else do I have? Miss Bishop is also 70 inches tall. Oh my goodness. 1, 2, 3, 4, 5, 6, 7, 8. Those are these 8 teachers that are within that height range. They're all numbers between 66 and 70. Now, if you did this, you could have different numbers and it could still be correct. There are many right answers because our histogram does not tell us specific numbers. This is just a possible set. All right, we got 6 pretty tall teachers between 71 and 75. 71, 71, 72, 73, 73, 75, 4, 5, 6. Got no 74s. And then one super tall. You know what? I'm gonna say this person is it. Maybe he's Mr. Dickerson. You guys met Mr. Dickerson? He's quite tall. Maybe he is 80 inches tall. So this is a possible data set for this histogram. Okay? One way you can check to make sure that you're not missing any is you can count all of this. We should get 26 because we know our total is 26. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 2, 3, 4, 5, 6. Okay, I have exactly 26. They all fit my my bin frequency. That is a possible set. Now, if you created a different possible set, what's cool is your numbers, if they are within these ranges and you have the frequencies correct, if I didn't have this picture, okay, and I asked somebody to make a histogram with my numbers, it should look like this. If I ask somebody to make a histogram with your numbers, it should look like that. If I ask somebody else to make a histogram out of your best friend's possible numbers, it should look like that. They will all look the same because we don't know for certain what the heights are. All right? Okay. Let me think. Is there anything else? Anything else about histograms? We covered our percentage, part over whole times 100. Oh, look at this. 31%. Is between this bin, right? Not the majority. A little bit more than a quarter. I think that's it. Okay, well, I hope this video helped. Thanks for watching. This is, again, a good way to study before any test or quiz you might have on histograms. And, all right. See ya.